Good afternoon, ladies and gentlemen. Thank you for joining me. This is section 3.4 in your textbook. So if you would, go ahead and get out your book and paper and pencil and get ready to take some notes on writing linear equations in slope-intercept form. Slope-intercept form is y equals mx plus b, where m is the slope of the line. I have to highlight that, where m is the slope of the line and b is the y-intercept. Okay, so if we have these two values, then we can write any equation in slope-intercept form. The y and the x are referring to an ordered pair that falls on that line. Okay, so you have the ordered pair here and here, and then the m and the b value represent the slope and the y-intercept. So those are the two values that I'm always going to be trying to find when I'm writing equations in this form. And once I get those two values, as you can see here, all I do is just plug them directly in for m and for b. We're going to have a few different scenarios that we're going to look at today. The first scenario is, what do I do when they just give me the slope and the y-intercept? Well, like I said, you just plug them directly in. So for the first example here, we have write an equation in slope-intercept form of the line with slope 3 and y-intercept of -2. Well, they gave me the two values that I need in the problem. So I'm going to take my slope of 3 and plug it in for m, and I'm going to take my y-intercept of -2 and I'm going to plug it in for b. And there I have my equation, y equals 3x minus 2. The other thing I wanted to talk about with this example is, how do I go about graphing the line after I have the equation? Well, to go about doing that, the best way to go about it is to first plot the y-intercept. And what does y-intercept mean? That is the point on the graph where the line crosses the y-axis. Okay, the y-intercept is the point on the graph where the line crosses the y-axis. So this line crosses the y-axis where y is equal to -2. So I'm going to start at my origin. I'm going to go down to y equals -2 and plot a point, just like you see that has been done here. Now that I have one point on the line and I know what my slope is, I can use my rise and my run to get more points on the line. So this is to get a starting point to be able to count the rise and run. Okay, so we plot the y-intercept, and then we rise 3, run 1, plot another point, and then draw our line. And that's the easiest, most efficient way to go about graphing a line in slope-intercept form. Your first step is going to be plot the y-intercept. Your second step is going to be use the slope to find more points. Now let's look at a different type of example for writing an equation in slope-intercept form. I realize in your book this section has slope-intercept and point-slope form. We are going to talk about point-slope form, but for the purposes of this unit, we're not going to talk about it yet. So in this problem, I'm going to change this to slope-intercept form instead of point-slope form. So we want to write an equation in slope-intercept form of the line with a slope of -3/4 that contains the point -2, 5. So it becomes a little more difficult when they don't just come right out and give you the slope and the y-intercept, but they have given me another crucial component, which is an ordered pair that falls on the line. I have an x and I have a y, and I have an m value. Okay, so let's go back and look at slope-intercept form and all the different variables that are contained. Okay, well, I have 4 variables total here. I have y, m, x, and b. Well, in the problem, they defined 3 out of the 4 values for me. They gave me the m value, they gave me an x value, and they gave me a y value. all in the problem. So now what I can do is I can take all three of these variables and plug them in their respective places in this equation. What that's going to do is leave me with only one variable left over for which I have to solve. So let's plug everything in where it goes and then see what it looks like. Okay, so y is equal to m, which has a value of -3/4, times x, which has a value of -2, plus b, which is the value that I'm trying to find. Remember, in the beginning I told you to write an equation in this form, we need the m value and we need the b value. Okay, well, they gave me one out of the two. I have to find the other. And once I get all this stuff plugged in, it's actually fairly simple from here, just multiplication and solving a simple equation. So I have 5 is equal to a +6/4, which would reduce to a +3/2, plus b. And I want to solve for b, which means I need to subtract 3/2 from both sides of this equation. That's going to eliminate 3/2 from this side. So what I'm left with now is that b is equal to 5 minus 3/2. Okay, so hopefully we all feel comfortable adding and subtracting fractions. And we'll get a little review here. I need to rewrite 5 to have a denominator of 2, which would look like so. And now that I have my common denominator, I can just subtract my numerators, and I have my y-intercept value of 7/2. So now I have the two values that I need. Remember, I told you in the beginning, if you can find the slope and the y-intercept, then you can write an equation in slope-intercept form. They gave me the slope in the beginning, and then I used that value along with the x and y to find my b value. So now I'm just going to plug in the m where it goes and the b where it goes in the general form, which would look like this. Y is equal to -3/4 x plus 7/2. So my finished product, I'm never going to have anything plugged in for y or x. The only time you should be plugging in for y or x is to serve some other purpose. Okay? Then in the directions it says to graph the line, so I do want you to get a little practice with that. So remember, the first step is going to be plot the y-intercept, and this is only for slope-intercept form. Okay? If it's in a different form, we would follow some different protocol. And then use rise over run. Okay, so I'm just going to sketch this real quick to kind of show you what I mean by that. So 7/2 has a value of about 3.5, so I'm going to go halfway between 3 and 4 and plot a point. And then from there, I'm going to go down 3 to 3/4, 1, 2, 3, 4, plot another point, and then draw a line. Okay? Not the prettiest, but you get the picture. Plot the y-intercept, and then use your slope from there to find another point. Okay, so what I want you to do now is I want you to take a few minutes, hit the pause button, and I want you to complete guided practice number 2 in your textbook with the same directions that we just used for this one. Not point slope form, but write the equation in y-intercept form and then graph the line. And we'll take a look at that together in class on Monday. Alright, your next situation is that you're given 2 points and asked to find, asked to write the equation of the line. So when you're given 2 points, you have enough information to get everything you need. What do we need? We need slope and we need y-intercept. Well, if I have 2 points, then I can use the slope formula to find my slope. Once I get to that point, now I'm in the same position I was before, where I have a slope and 2 points to choose from. Okay, where before they only gave me 1 point, well, now I have 2 points. Okay, so when you're given 2 points, you first find the slope, and then you just pick one of these 2 points and do the same thing we did last time. Plug in x for x, plug in y for y, plug in m for m, and solve for b. But this is kind of a special case because of this point right here. They've actually given me the y-intercept without actually coming out and saying, hey, here's the y-intercept. All points that fall on the y-axis will have an x value of 0. Okay, here's my x and y-axis. And let's plot the point 0, 3. Well, we're not going anywhere left and right because my x value is 0. I'm going up to 3 and plotting the point there. Well, think about every point that has an x value of 0. That's always going to be the case. You're never going to move to the left or to the right before you plot your point. So you're always going to fall on the y-axis. If you have an x value of 0, your point will always be on the y-axis. So try to be cognizant of that and pay attention, because they're actually helping you out here. They're actually letting you skip a step. I don't actually need to go in and plug in x for x and y for y and m for m and solve for b. All I need to do is find my slope, know that this is my y-intercept, and plug those 2 values in. Okay? Plug in 2 for slope and plug in the y value of the y-intercept for b, and you're done. Y equals 2x plus 3. Then if I wanted to graph the line, I would plot my y-intercept at 3 and then use my rise and run, go up 2 over 1 or go down 2 left 1, either or, and then draw my line through the 3 points. Let's do an example similar to this where they do not give us the y-intercept in the problem, okay? Because more often than not, one of the 2 points that you're given is not going to be the y-intercept. So what do we do there? Well, we still want to find the slope first, because that's what we're looking for all the time with these type problems. I need my m value and I need my b value. Well, anytime I have 2 points, I can always use those 2 points and the slope formula to find the slope between them. So I'm going to plug in to find my slope here, and I end up with a negative 8 over 16, which reduces to negative 1/2. Okay, so that is one of the 2 values I need. I need slope and I need y-intercept. Okay, well, how am I going to find my y-intercept? The same way we did in example 2 at this point. Now what I have is slope and a point, or points in this case, to choose from. And you choose whichever one you want. I'm going to choose my first point here. If you want, you can choose the second point while you're working this with me, just to see that it doesn't matter which point we choose. But I'm going to plug in the y value from point 1 for y. Then I'm going to plug in the slope that I just found for m. Then I'm going to plug in the x value from this first point. And then I'm going to solve for the y-intercept. This is going to end up as a positive 7 over 2. And then I need to subtract 7/2 from both sides. So b is going to be equal to 4 minus 7.